Chapter 1, a square and a cube. Square, we know that the figure with all four sides in equal length. That type of figure we can say that is square. And we know that area of that square is equal to side into side. If the side is with 1 unit, then area it will come 1 into 1 is equal to 1, that much square unit. If the side with the 2 units, here 2, this side also 2, then it will come 2 into 2 is equal to 4. Similarly, with the 3 units as the side, three into 3 is equal to 9 square unit. The small squares we can see here 1, 2, 3. This side also 1, 2, 3. 3 into 3, total 9 small squares are there inside that bigger one. It will continue like the same way. 4 into 4 is equal to 16. 5 into 5 is equal to 25, etc. So these numbers are called square number or perfect squares. 1, 4, 9, 16, 25, etc. These numbers are called square number or perfect squares, which means any natural number if we multiply with the same number one more time, for again one more time with the same number, 5 with the same number. So any number multiplied by with the same number one more time, then we will get the perfect squares or square numbers. This we can write as 1 into 1. 1 we multiplied 2 times, which means 1 square. 2 here we multiplied 2 times, so 2 square. 3 2 times, which means 3 square. This in exponents we know that the power or exponent, and this the base. 3 2 times we are multiplying. Here 4 2 times we are multiplying. So this we can write as 2 square is equal to 4, 3 square is equal to 9, 4 square, which means 4 into 4 is equal to 16. These numbers are called square number or perfect square. Here we can see the same way that table. Side length of that 1 unit, then area it will come 1 into 1 square unit. Side length is 2. Then it will come 2 into 2, 4 square unit as the area. It is continuing. Here side length is 10 unit, then 10 into 10, 100 square unit. Figure also like the same way, 1, 2, 3, 4, 5. So 5 as the side length. This side also 5, 5 into 5, 25 square unit we will get. Now that we can write as 1 into 1, which is equal to 1 square. And that is same as 1. 2 into 2, 2 square is equal to 4. So 2 times when we are multiplying, that we can write in exponential form or power as 2. And these numbers are called square number. Here in general, n into n is equal to n square. This we can do in any number. That means fraction, decimal, negative number, anywhere. For example, fraction 3 by 5 the whole square, which means that 3 by 5 we have to multiply 2 times. We will get 9 by 25. In the case of decimal, 2.5 square. So 2.5 into 2.5, we think here 6.25. In same way in negative numbers, negative integers also we can do the same. Minus 6 into minus 6 is equal to minus into minus, it will come positive. 6 into 6, 36. So we can write that as minus 6 the whole square is equal to 36. Product will be always positive. Here it is given a number, the definition of that, a number that can be expressed as the product of a number with itself is called square number, or we can say that is square. That's the definition of a square number. 1 into 1, 2 into 2 is equal to 4, and that number is called the square number. A number that can be expressed as the product of a number with itself. 2 into 2, product of these two, that 2 times, and that product 4 is called the square number. Here 3 into 3, 9 is the square number. 4 into 4, 16 is the square number. 1 into 1, 1 itself. So these are the square number. Now the numbers have odd number of factors are the squares. Square number have a odd number of factors. We know the prime factorization of these numbers. Here 1 is the only one factor. 4 we can write as 1 into 4 and 2 into 2. So total 1, 2 and 4 are the factors. So odd number, 3 factors are there for the square number 4. Why the odd number of factors is coming? Because one table is coming with the same number. Repeating that 2 into 2. Here 3 into 3. So here 2 factors and here only 1 we can take. 1 time 3. So 3 factors is having for 9. That's why here the odd numbers, an odd number of factors for the square number is having. The squares of natural numbers are called perfect squares. That means these numbers are called square numbers or squares or perfect squares. Now patterns and properties of perfect squares. Here 1 square means 1 into 1, 1. 2 square, 2 into 2, 4. 4 square. Here to complete the rest of the numbers. 6 square. We know that using the table 6. 6 into 6. 36. 7 into 7, 49. 8 into 8, 64. 9 into 9, 81. 10 into 10, 100. Then here 11 square is given 121. 12 square, 12 into 12, 144. 13 into 13, it will come 169. 14 square, 14 into 14, 196. 15 into 15, 225. 16 into 16, 256. 17 square, that means 17 into 17, 289. 18 into 18, 324. 19 into 19, 361. 20 square, that is easy. 2 into 2 or 2 square, that is 4. And in place of 1 0, we have to double that also, 2 zeros. Here also same way. 1 square is 1 and 1 in place of 1 0, it will become 2 zeros. Now here 21 square is given. 22 square, 484. 23 square. Next number, we can write any number there. So continuing like the same way up to 30. 23 square, it will come 529. 24 square, 576. 25 square, 625. This we have to remember always. 25 is for questions is coming. So 25 square, we can remember that. Rest of that we can multiply and get it. Few of them, if you are remembering that a square number, and it is, that will be easy or time saving when we are doing the questions. 26 square is 676. 27 square, 729. 28 square, 784. 29 square, 841. And 30 square same way, 3 square, that is 9, then 2 zeros, 900. So these are the square numbers or perfect square. These numbers are called perfect squares. 3 names: perfect squares or squares and square number. Now from here, what the pattern do you notice? We can see the number ending. The square now square of a number that is ending with 1, 4, 9, 6, 5, 6, 9, 4, etc. So we can mark that none of them end with 2, 3, 7 or 8. So remember that these numbers, that is easy to remember, 2, 3, 7 or 8. No number, no square number, it will end with 2, 3, 7 or 8. So any number, if we are getting that as, for example, 463, 3 is coming in the unit place, that is not a perfect square. Then 878, 8 is coming there, that also not a perfect square. The numbers ending with 2, 3, 7 or 8. Any number with 7, 537, ending with 7, which means it's not a perfect square. So this hint we can remember that 2, 3, 7 or 8. Any number ending with this digit, then that number is not a perfect square. Now here the next question. If a number ends with the rest of the digits, 0, 1, 2 is here, 3 is here, 4, 5, 6, 7 and 8 is there. So 9. We already said the any number ends with 2, 3, 7 or 8, that is not a perfect square. Now the question is, otherwise, if the number is ending with the other digits, then always a square. That also we cannot say that always a square. This is just a clue or hint to then the first look itself to predict the given number is a square or square number or not. Now here write 5 numbers such that you can determine by looking at their units digit that they are not squares. Not squares means ending with these digits. So we can write any number, 5 numbers they are saying. So 578 ending with 8. Then 3023 ending with 3. Then 467 ending with 7. Then which digit? 2. So another number 2. So 2, 3, 7 or 8. One more number, 5 numbers required. So any number you can write. Ending with 8. So like that way many numbers we can write. Any number ending with 2, 3, 7 or 8. These are not perfect squares. So that's the question here. Write 5 numbers such that they by looking at their units digit. Also here we can see a pattern in the unit place digit of a square number. Unit place digit of a square number. 1 into 1, that will come 1 itself. 9 into 9, 81. So both ending with 1. 1 into 1, 1. 9 into 9, 9 into 9, 81. But unit place digit is 1. Similarly, 2 into 2, 4. And 8 into 8, 64. So both ending with 4. 2 into 2, 4. 8 into 8, 64. But unit place digit is 4. So any number ending with 2 or 8, its square's unit place digit will be 4. Similarly 3. 3 into 3, 9. 7 into 7, 49, that also ending with 9. 4 into 4, 16. 6 into 6, 36. Both ending with 6. And 5 square is 25. So that is ending with 5. So we can remember this the way. Any number ending with 5, its square, that also will be ending with 5. 6 and 4, it will come at the unit place 6. 7 and 3, 9. 8 and 2, 4. 1 and 9. 1. And if it comes 0, that will 1 0 in the number having, then its square is will be having 2 zeros. Here 2 zeros, then here it will come 4 zeros. So number of zeros in the unit place, that will double. This is what here it is given. You can see here any number has 1 or 9 in the unit place, then the square ends with 1. 1 or 9 in the unit place, then the square ends with 1. Similarly, here some examples are given. Ends with 6, that means 4 and 6. Here 4 and 6. Any number with 4, for example 14 and 26. When you are taking the square of that, 14 square, that will end with 6. 26 into 26, that also will end with 6. So unit place digit will be 6. This is the unit place digit of the number, and these are the unit place digit of the square number. Here the question, which of the following numbers have the digit 6 in the unit place? We can write that, take the unit place digit 8. 8 into 8, 64. So 6 will not come. Here the digit at the unit place will come 4 only. We know that here 8, if the number is with 8 in the unit place, that square number will end with 4. 8 into 8, 64, 4. Here 4. 4 into 4, 16. So unit place digit will be 6. 6. 6 into 6, 36. So unit place digit will be 6. Here also 36. 4 into 4, 16. Unit place digit is 6. 2. 2 into 2, 4. So unit place digit is 4. Here the question, which of the digit have the digit 6 in the unit place? So the 2, 3, 4, 5. All these 4 numbers having 6 in the unit place digit. This also by using the same. If the number ending with 4, then square number is having the unit place digit 6, or the number ending with 6. Now find more such patterns by observing the numbers and their square from the table you filled earlier. Here this table. So by using that, the same pattern what we are getting. Any number ending with 1 or 9, you will get the number, square number ending with 1. Any number with 2 or 8, that unit place digit will come 4. 3 or 7, it will end with 9. 4 or 6 end with 6, and 5 it will end with 5 itself. The number of zeros, that will be doubled in the square number. If you consider the following number and their squares, 10, 1 0, it is coming 2 0. 2 square is 4 and double the number of zeros, 2 zeros. 4 square is 16, not 8. 16 and then 2 zeros more. So it will come 1600. Here 2 zeros, double that number of zeros, 4 everywhere. 2 square 4, 7 square 49, 9 square 81, and then double number of zeros. Here 2, which means 1, 2, 3, 4 zeros supposed to come. Here 4, here also one more 0 it will come. 4 zeros. If a number contains 3 zeros at the end, how many zeros will its square have at the end? 3 zeros of the number, and then how many zeros will be its square? Double that number of zeros. Here 3, 3 plus 3, 6 zeros. So the how many zeros will its square have at the end means 6 zeros. What do you notice about the number of zeros at the end of the number and the number of zeros at the end of the square? That means end of the number how many zeros, and end of the square that will be double number of zeros. Can we say that the square can only have an even number of zeros at the end? Yes. If here 1, it will come 2. Here 2, that will come 4. Here 3, that will come 6. So always it will end with even number of zeros. What can you say about the parity of a number and its square? You can say a number is multiplied by itself. Then we will get the square of that number. Now, perfect squares and odd numbers. There is a connection between the square number, perfect squares and odd numbers. Here we can see 1, 4, 9, 16, 25, 36, etc. These are the perfect squares or square number. And here we are getting the odd numbers list, which means we can write all the perfect squares as the sum of odd numbers. Here 4 is 2 square. So sum of first 2 odd numbers. First 2 odd numbers 1 and 3. 1 plus 3, 4. 9 is 3 square. So sum of first 3 odd numbers. Odd numbers we know that 1, 3, 5, 7, 9, etc. So sum of 3 odd numbers means 1 plus 3 plus 5. 16, that means 4 square. 4 into 4 is 16. So take 4 odd numbers sum. 1 plus 3 plus 5 plus 7. When you are adding 1 plus 3, 4, 4 plus 5, 9, 9 plus 7, 16 will get. Similarly here 5 odd numbers. Here 6 odd numbers. Sum of 6 odd numbers is equal to 36. That we can arrange. This is square. We can arrange that in terms or in the form of an odd number. Here 1, first number 1, then 3, here 5, then it is 7, 9, 11, etc. Like that way, whatever the numbers come, we can arrange the square numbers. Square numbers we can arrange the form of a square. Number of dots in each side, that will be same. Here 6 square dots, this side also 6 dots, all 4 sides with the 6 dots. That means it's the form of a square. 6 into 6, 36. The same square we can write or we can pattern that. We can mark the pattern like the same way as the sum of odd numbers. Sum of 6 odd numbers. From the first, starting with 1, then 3, 5, 7, etc. This is the pattern. If the perfect square or the square number 4, we can write as the sum of 4 means 2 square. So sum of 2 odd numbers 1 and 3. 1 plus 3, 4. So we can write 2 square, 2 into 2, 4. Perfect square. And when we are marking that in this form, in terms of odd numbers, 1 here separate and then 3. Same next one, it is here 3 square dots on each side. So 3 square, which means 9. This 9 we can mark it as first with 1. Then next row that is coming with 3. And after that 5. Here we can see 4 dots in one side. So 4 square. That means 16. So first one here like the same, then group of 3, then group of 5 and then group of 7. So the square we can divide according to this pattern as the sum of the odd numbers. Same way we can find the square number, or we can check the given number is a square number or not. For example, here 25 by subtracting, repeated subtraction method. So when we are adding 1 plus 3 plus 5 odd numbers, 1, 3, 5, 7, 9. When we are adding this all, we are getting 25. We know that sum of 5 odd numbers. So it will come 5 square and that is equal to 25. Same thing we can check by subtracting. 25 is the number. So 25 minus 1, we will get 24. Then that first we subtract 1, then subtract next odd number 3. Now it will come 21. From that next odd number 5. It will come 16. Again next odd number 7. It will become 9. Next odd number 9. Then 9 minus 9, 0. So after subtracting these odd numbers, if you are getting 0, which means that number is a perfect square. That's the example here. We are taking 16. That also same as that. 16 means 4 square. So this 16 we can write as the sum of 4 odd numbers. Odd numbers we know that 1, 3, 5, 7, 9, etc. First 4 odd numbers. So 1 plus 3 plus 5 plus 7. Again 16 minus 1. We will get 15. 15 minus 3. We will get 12. 12 minus 5. 7. 7 minus 7. 0. That means 16 is a perfect square or it's a square number. So same way how we are adding the odd number from 1, how many numbers we are adding, and that will be the 4 numbers if we are adding 4 square. It's equal to 16. That will be the sum of these odd numbers. That we can check by subtracting odd numbers same as that from the beginning 1, 3, 5, 7, etc. Finally if we are getting 0, then we can say the given number is a perfect square. Another example, if we are taking 12, we know the odd numbers are this. 12, just check 12 is a perfect square or not. For that first we have to minus the first odd number 1. We will get 11. Then next odd number 3. Minus 3, it will come 8. Then next odd number 5. 8 minus 5, 3. Next odd number 7. We cannot minus 7. If we are minusing 7, it will come minus 4. So we are not getting 0. Which means this 12 is not a perfect square. Only for perfect squares, we can write that number as the sum of the odd numbers, or the same way, just opposite. We can subtract by repeated subtraction method. Odd numbers we have to subtract and finally we will get 0 if the given number is a perfect square. Using this pattern above, the same pattern, find 36 square. Here given that 35 square is equal to 1225. We have to find the next number, 36 square. So we know that we have to find the odd number of that last term, odd number of the last term. To find the odd number, 36 is the number. To find the odd number of that, we have to use the nth odd number is 2n minus 1. This rule. So 2 into 36 is 72. 72 minus 1, 71. So we have to add 71 to 1225. We will get 1296. That will be 36 square. So for that, which number we have to find, and find the odd number, the last odd number. For that, use this formula. 2n minus 2n will be an even number. 2 into any number, we will get an even number, that minus 1. So 2n minus 1. 2 into 36, 72 minus 1, 71. Then add that number. Here just to check 38 is a perfect square or not. Same way we have to minus all the odd numbers starting with 1, then 3, 5, 7, 9, 11. After that last we are getting, when we are subtracting 13 from that number, minus 11. Which means this 38 is not a perfect square. We have to get 0. If that is a perfect square, always the last digit when we are subtracting, that will be 0. So 38 cannot be expressed as the sum of consecutive odd numbers starting with 1. 38 is not a perfect square, so we cannot write as the sum of consecutive odd numbers. Here the question, find how many numbers lie between two consecutive perfect squares. Do you notice any pattern? There are also a pattern. For example, if you are taking n and n plus 1, that means two consecutive perfect squares. First number is n square, next number is n plus 1 square. And in between these two numbers, there will be 2n numbers. In between these two square numbers, there will be 2n numbers. 2 into first number. For example, if we are taking the square number 1 and 4. So, first number we have to take 1 and 2. N is equal to 1. N plus 1 means 2. When we are squaring that, it will come 1 and 4. And in between this 1 and 4, we know that 2 and 3. Two numbers are there in between this square number. And like this way, how many numbers? The rule is 2n. 2 into first number. 2 into 1, 2. That means 2 numbers there. Next, if we are taking the consecutive numbers as 2 and 3. And it's a square. It will become 4 and 9. So according to this rule, 2n, 2 into 2, 4 numbers will be in between 4 and 9. We know that 5 in between after 4. 5, 6, 7, 8. 4 numbers are there in between that. This is the way we can find out how many numbers are there in between two consecutive numbers squares. If we are taking 5 and 6, two consecutive numbers 5 and 6. And its square means 5 square and 6 square. So it will come 25 and 36. In between these two numbers, how many other numbers are there? These are the perfect squares. So in between these perfect squares, how many other numbers are there? That means 26, 27, etc. up to 35. That will be, according to this rule, 2 times of that first number. 2 into 5. 10 numbers will be there in between 25 and 36. This is the pattern what we got, that we can write it here. How many numbers lie in between two consecutive numbers perfect square? If we are taking the numbers as n and n plus 1 and its square. So n square and n plus 1 square. Then how many numbers lie between these perfect squares? Which means 2 times of the first number. That many numbers will be there in between the perfect squares of these two. Here we can write any example like the same way, many more. If we are taking 9 and 10, square of that number. Square of that number means 9 square and 10 square, which implies 81 and 100. So how many numbers will be there in between 81 and 100? These two are perfect squares. So in between, how many other numbers are there? From 82, 83 up to 99 between these two. So to calculate that, we have to take the first number, 2n, which means 2 into 9. First number 9 is equal to 80 numbers will be there in between these two. In between 9 square and 10 square. This is the rule, 2n. Here, how many square numbers are there between 1 to 100 here? How many square numbers are there? So this, by looking the previous table what we filled, based on that, by looking that, we can write it here. In between 1 to 100, we can see the first column. So from the table we can write in between 1 and 100. Now in between means included 1 and 100 we have taken here, that is 10. In between, otherwise you have to write that is 8. 1 is a perfect square, 100 also a perfect square. So including 1 and 100 it will become 10. And in between 100 and 1, 204, here 3, again 3, here 2, is all 2. And 900, in between 900 and 1000, it is coming only one number. We know that 30 square is equal to 900. Then 31 square is equal to 991. 32 square, that is coming as 1054. So in between 900 and 1000 only one number is coming. 900 already included here. From 901 to 1000 it is coming only 31 square, one number. So this, from by looking the table we can write it. Here perfect squares and triangular pattern. Here we can see a pattern 1, 3, 6, 10, 15, etc. If you are taking that as any number of dots in the base line, n into n plus 1 by 2, total number of dots that will be according to this pattern. If we are taking 1 into 1 plus 1, 2, 2 by 2, it will come just one dot. Here 2 dots are there. So 2 into 2 plus 1, 3 by 2. 3 total 3 dots. Here 4 dots are there. So n is 4. 4 into 4 plus 1, 5 by 2. 2 into 5, 10 dots. Here 5 dots are there. So in place of n we can put 5. 5 into 1 more. 6 by 2. 5 into 3, 15, total 15 dots. So this triangular form it is going according to this pattern, n into n plus 1 by 2. Now here the square pattern. Same thing, same number of dots here, they are arranged in different way. Here 1 plus 3, 1 plus 3, these two adding. These two together we are getting 4. That is 2 square, which means 4 is a square number. Next 2. 3 and 6. 3 plus 6, 9. 9 is a square number. 3 square, 3 in each side. Next 6 plus 10. 16, that means 4 square. The next pattern, we have to continue the next term. So 10 plus 15. So we can write here 10 plus 15 is equal to 25. That means 5 square. So we have to make 5 dots in each side. Now 5 in each side. So it's a square. This is the pattern in between triangular numbers and square numbers. When we are adding these two, we will get a square number. Nearest to triangular numbers, when we are adding the square number, we will get the square number. 10 plus 15 is equal to 25. That means 5 square. So we can arrange that 25 dots in this order, in the square number form. Next is square roots. Here 49, we know that is 7 into 7 is equal to 49. So square root means, for example, 7 into 7 is equal to 49. Square root sign we are representing like the same way. Square root of 49 is equal to 7. So 49 is a square number. Square root of that, this is the symbol, square root of that number is equal to 49 is equal to 7. Also here we know that 7 into 7 is equal to 49, and the negative number, if you are taking minus 7 into minus 7, also is equal to 49. Minus into minus plus. 7 into 7, 49. So when we are taking the product positive 7 7 into 7 and minus 7 into minus 7. Same answer we are getting. Similarly, or the same way, when we are taking the square root of that, the answer can be positive 7 or negative 7. So that we will write as plus or minus 7. But in this chapter, we are going to learn about only the positive answer. So root of 25, we are getting the answer, both it is correct, plus positive 5 and negative 5. But here in this chapter, we are going to discuss about the positive number, square root of the positive number. That is here given. What is the square root of 64? 8 into 8 is 64 and minus 8 into minus 8 also 64. Which means 8 square is equal to 64 and minus 8 square also is equal to 64. Then when we are taking the square root, this is the square root sign denoted by this symbol. Square root of 64 is equal to plus or minus 8. Similarly, 100 plus or minus 10. So any number, square root of any number, that will come plus or minus. Here it is given in this chapter, only consider the positive square root. Given a number such as 576 or 727, how do we find out if it is a perfect square or not? We know the rule that any number ending with 2, 3, 7 or 8 is not a perfect square. So 327 is ending with 7. So we can write 327 is not a perfect square according to this rule. Now what about 576? This is a big number, so by repeated subtraction to find, we can subtract by odd numbers. So finally we will get 0 or not. It will take time. Another method is by prime factorization method. When we are doing the prime factorization of 576, we are getting here 2 times of that 2 6 times and 3 2 times. So 576 we can write with these prime numbers, prime factors product. And square root of that number, which means square root of this prime factors. So when we are taking the square root, we have to consider this as a group, as a pair. Now, two 2's together as a pair. And out of that, 1 we have to take. 2 into, from this group, another 2. Next group, again, 1 more 2. And from this group, 1, 3. So which is equal to 2 into 2, 4, 4 into 2, 8, 8 into 3, 24. So we are getting the answer root of 576 is equal to 24 or 24 into 24, which means 24 square, that is equal to 576. 576 is a perfect square and its square root is coming 24. So to find the square root, we can do different method. One is the repeated subtraction method. Second one is the prime factorization method. Repeated subtraction method we can use only for small numbers. For example, 25. You have to subtract the odd numbers. Odd numbers means 1, 3, 5, 7, 9, 11, 13, etc. So subtract that from the given number. 25 minus 1, we are getting 24. Again minus 3, 21, minus 5, 16, minus 7, 9, then minus 9, 0. So if you are getting 0, we can say that number is perfect. This is one of that method. And here the square root, how to check how many times we subtracted. Here we can see 1, 2, 3, 4, 5 times we subtracted, which means square root of 25 is equal to 5. We have to get 0 at the end and also how many times we did the subtraction work. That will be the square root of that number. So for bigger number, it will take time and it is not easy. Prime factorization method is easy for us to find the square root. Here another number is given 81. Same way we are subtracting 1, 3, 5, 7, 9, 11, 13, 15, 17. Finally we got the answer 0. Last step is 0. If we are getting 0, and we have to check how many steps we have done. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means square root of 81 is equal to 9. So we got 0 in the 9th step. We can write root of 81 is equal to 9. But for bigger numbers, it is not easy. We will follow the prime factorization method. That is here. 324 is a perfect square. We have to do the prime factorization and we are getting 2 times 2 and 4 times 3. So from here we can take 1, 2. From here 3 and make the pair. Then from there we have to take 1 only. So 2 into 3 into 3. 3 into 3, 9. 9 into 2, 18. That is the answer. Now next number 156. 156 also, when we are doing the prime factorization, we are getting 2 times 2. But 1 time 3 and 13. Which means that is not in the form of 3 is only 1 time. Not a pair. 13 also 1 time. If there is cannot a pair up these factors, that means the given number is not a perfect square. Then we can make this number as a perfect square by multiplying and 1 more 3 and 1 more 13. So not 156, we will get another number, a perfect square. Here the question, 156 is a perfect square or not. So we can write there is not 3 and 13 doesn't have pair. So which means 156 is not a perfect square. Now find whether 1156 and 2800 are perfect squares using prime factorization. We can do the prime factorization of both the numbers. When we are doing prime factorization of 1156, we are getting 2 times 2 and 2 times 17. So square root of that number is equal to square root of this. Then we have to make as a pair, 2 in a group. Same number. So which is equal to, we have to take 1, 2 from that. 117, which is equal to 34. That means square root of 1156 is equal to 34. 289 and that all square root we can find from the previous table. For this table we can use it to find the square root of some of these numbers in the beginning. Next number 2800. When we are doing the prime factorization, we are getting 4 times 2, 2 times 5 and only 1 times 7. This number is not having pair, which means it is not a perfect square. Not a perfect square. We have to get even number of or pair of each prime number. 7 is not having the pair, so we can write this given number 2800 is not a perfect square. So in this chapter, what we have learned in the first part of the first topic, we can just summarize like that. The definition of square. A square of a number is the product of the number with the number itself. Square of 3 means 3 square. 3 into 3. 7, square of 7 means 7 square. We can write that as 7 raised to 2, 7 square, and that is equal to 7 into 7 is equal to 49. Now some properties of these perfect squares. Any number ending with 2, 3, 7 or 8 at unit place, then the number is not a perfect square. So 2, 3, 7, 8. Any number ending with these digits, the given number we can write is not a perfect square. Another property, number of zeros at the end of a perfect square is always even. 2, 4, 2 zeros, 4 zeros, then 6 zeros, 8 zeros, like that way. Even number of zeros will be. Next property, the square of an even number is always even. Square of an odd number is always odd. These are the few points which one we have to remember when we are doing the calculation work about the perfect squares. Now square root, we already noticed that 7 into 7, 49, and minus 7 into minus 7 also is equal to 49. So we can write 49 as the perfect square number, and then square root of that 49, it will come plus 7 or minus 7. But we are considering here this chapter only positive numbers. Square root of 49 we can write together plus or minus 7. If we are writing like this, which means plus 7 or minus 7 can be the answer. Root of 64 plus or minus 8, etc. Like that way it will come. Figure it out. Page number 10. Which of the following numbers are not perfect squares? Just by looking, we know that the number ending with 2, 3, 7 or 8 are not perfect squares. So this one we can write the number ending with 2. So 2032, this number is not a perfect square. Here this number is ending with 8, which means this also not a perfect square. Ending with 7, not a perfect square. Here the number ending with 9, so we can say that this number may or may not be a perfect square. This is one of the rule. Ending with 2, 3, 7, 8 are not perfect squares, but with other digits are not compulsory always that is perfect square. This we have to check by using the prime factorization method and find out it's a perfect square or not. When we are doing the prime factorization, we can see that this number also not a perfect square. Second question, which one among has last digit 4? So 4 square, it will come last digit 4 into 4, 16, 6 is the last digit. 8 into 8, 64, 4 is the last digit. 2 into 2, 4. 6 into 6, 36, so 6 is the last digit. Here the number which one has the last digit 4, which means 108 square and 202 square. Here given 125 square is equal to 15,625. What is the value of 126 square? We already noticed that rule, the pattern, that is we had to find out the previous odd number, which means odd number, to get the odd number, the rule 2n minus 1. 2 into n, even number, that minus 1. Here in place of n, that is 126. So 2 into 126. 126 into 2, it will come 252. That minus 1, that means 251. 2n minus 1, 251. So we had to add 15,625 plus 251. That means this answer is correct. Use the rule 2n minus 1. The given number is 126. 2 into 126, 252. That minus 1, 251. That odd number, the last odd number. This rule we are using to find the last odd number. So this one plus that last odd number. Fourth question, find the length of the side of a square whose area is 441 meters square. Area is 441 meters square. So we know that the area of a square is equal to side into side, and then we can write that side into side, which means side square is equal to 441. Then we had to find the square root of that 441 by prime factorization method. Here we cannot divide by 2 first prime number, then next number 3. By divisibility test, 4 plus 4 8, 8 plus 1 3 9, that means we can divide by 3. Here 1 time in 14, 4 times 21, 7 times. One more time with 3, 4 times 12, 2, 27, 49, then with 7. So we can write 441 as 3 into 3 into 7 into 7. Now we have to find the square root to find the side, which means we have to find the square root of 441. Square root of that is equal to, we have to take just 1, make it pair, and 1 from that. 1 3 and 1 7 is equal to 21. You can write therefore side of the square is equal to 21 meter. Fifth question, find the smallest square number that is divisible by each of these following. To find the smallest square number, first we have to find the LCM of the given numbers 4, 9, 10 by prime factorization method. Now when we are doing the prime factorization, we are getting here LCM of 4, 9, 10. 2 into 2 into 3 into 3 into 5. So the LCM, that means 180 is the LCM. So which means we can write 180 as the product of these numbers 2 into 2 into 3 into 3 into 5. If 180 is a perfect square, we can group as a pair. But here we can see 2 and 3 are the pair. 5 only one time. So that means 180 is not a perfect square. Here the question, find the smallest perfect square. So to make this number as a perfect square, we have to multiply both the side with 5. Here 180, that side with 5, to make the other side also as a pair, to make the pair for that 5. Now we are getting here each one with a group of 2. Here the number is coming 900, which means 900 is equal to 2 square into 3 square into 5 square, which means a perfect square. So we can write the required smallest square number is 900. So we had, what we did, first we had to find the LCM of that number. We got that as 180, but for 5 there is no pair, so we multiplied both the side with 5, left side and right side with one more 5. After that we are getting the number 900, and that 900 we can make as the group of 2, each prime factor. So from that, when we are taking, we are getting 30 as the square root of 900, which means 900 is the smallest square number which is required. Question number 6. Find the smallest number by which 9408 must be multiplied so that the product is a perfect square. Find the square root of the product. So first we had to prime factorize the given number, and after that check which is the number is not having pair. Multiply by that number one more time to make that as a pair, and we will get the new number, new square number. First we have to do the prime factorization. When we are doing the prime factorization of this number, we are getting 9408 is equal to 2 square into 2 square into 2 square into 3 into 7 square. 7 2 times is there. 2 we can take it, group it like this way, but 3 only one time, which means we have to multiply both the side with one more 3. So this side 9408 multiplied by 3. Same way the other side, when we are multiplying 3 into 3, it will become 3 square and 7 square. So when we are multiplying here, we are getting 9408 into 3, it will come 28,224. So this is the new number. Square root of that means square root of this all. 2 into 2 into 2 into 3 into 7, which is equal to 252. So we can write 28,224 is the new number and its square root is 252. Here the number. How many numbers lie between the squares of the following numbers? How many numbers lie between the squares of this number? That means 16 square and 17 square. Between the squares of 16 and 17. Which means in between 16 square and 17 square. There is a rule 2n numbers in between the squares of consecutive numbers. N means the first number we have to take. So 2 into 16. 2 into 16 which means 32. So 32 numbers will be there in between the square of 16 and 17. Here 2n means 2 into 99 is equal to 198 numbers are there in between 99 square and 100 square. Question number 8. In the following pattern, fill the missing numbers. First we have to look at the given numbers and find the pattern. Here 1 square plus 2 square is equal to 3 square. 2 square plus 3 square. Here 6 is coming, which means 2 into 3, 6. And the next number 7. 3 into 4, 12. Next number is 13. Now we got the pattern. Next we can do that. 4 into 5, 20. Next number is 21. After 20, 21. Here 9 into 10, 90. And the next number is 91. So first we have to find out the pattern and we can continue how many more we want. Now how many tiny squares are there in the following picture? Try the prime factorization of the number of tiny squares. So we can write in step squares in one row. Here we can see 1, 2, 3, 4, 5, 6, 7, 8, 9 in one row. Same way in one column also 9 squares. Each column, that is 9 squares. So in a row 9 squares, in a column also 9 squares. Now look at one square and how many small squares, tiny squares are there. We can see 5 in one side. So 5 into 5, 25 small squares are there. In each small square contains 25 small squares. So total number of tiny squares, which means first we have to find how many squares are there. In a row 9 and in a column 9. So 9 into 9. And in each square is having 25 tiny squares. So total small tiny squares is equal to again 25. So we are getting the answer 9 into 9 into 25 is equal to 2025. Now again here prime factorize that number. That means 2025 when we are doing the prime factorization. Already we know that here 9 into 9 into 25 is equal to that number. So prime factorization of 9, that is 3 into 3. Again one more 9, 3 into 3. And then 25, that means 5 into 5. So the prime factorization of that number is coming like the same. Now we can find the square root of that number. 2025, which is equal to, make a group of 2. So 1 time 3, again one more 3, this 5. So 3 into 3, 9, 9 into 5, 45. So we can write square root of 225 is equal to 45 or 2025 which is equal to 45 square. So that's the prime factorization of 2025. Cubic numbers. Cube, which means a number which is multiplied 3 times. Then the product, that number is called cubic or cube. Now here this is the cube of with 1 centimeter. So it has 3 dimensions: length, breadth, height. All 3 dimensions are same. Then we can say that is cube. Example, dice, Rubik cube, etc. Now the same way here 2 unit is coming as the length, breadth and height also 2 unit, this one. So cube of this 2 into 2 into 2, 3 times length into breadth into height, all 3 measurements with the same unit. 2 into 2 into 2 is equal to 8. 2 into 2, 4, 4 into 2, 8, which means 2 cube is equal to 8. 2 3 times when we are multiplying, we are getting 8. Here, how many 1 centimeter cubes contains in a cube of 3 centimeter? In place of 2, it will come 3. So each side 3 centimeter. 3 into 3 into 3. 3 into 3, 9. 9 into 3, 27 unit. And how many 1 unit or 1 centimeter cubes can fit in that? So that divided by 1 into 1 into 1, which is equal to 27 divided by 1, and that is equal to 27 itself. So 27, these type of cubes, when we are arranging in this form, then we will get the cube of side 3 centimeter. 27 cubes is the answer. Here the numbers 1, 8, 27, etc. These type of numbers are called perfect cubes, which means any number if we multiply 3 times. Here 1 3 times when we are multiplying, we are getting 1 itself. 2 3 times, 2 into 2 into 2, 8. 3 into 3, 9, 9 into 3, 27. So these type of numbers are called perfect cubes. Here the question 9 is a cube. Now 9 we can write just 3 into 3 only, not 3 times. So it is not, you can write no. 9 is not a cube. The number 8, 27. In between 9 is coming. So 9 is not a cube. Can you estimate the number of unit cubes in a cube with an edge of 4 units? Edge is 4 unit, which means length, width and height. All 3 dimensions with the same 4 into 4 into 4 is equal to 4 into 4 16, 16 into 4 64. Same way with 5 unit, it will come 5 cube. 5 3 times we have to multiply, then we will get that as 5 cube is equal to 125. So in general we can write for any number n as the number of small cubes in that is equal to n cube, or cube of that number is equal to n cube. Here we can see the numbers. 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube means 4 into 4 into 4. This exponent 3. 4, 3 times we have to multiply. 5 into 5, 25, 25 into 5, 125. Now 6 cube, 6 into 6, 36, 36 into 6, it will come 216. 7 into 7, 49, 49 into 7, 343. 8 into 8, 64, 64 into 8, 512. 9 into 9, 81, 81 into 9, 729. 10 into 10, 100, 100 into 10, 1000. Here in place of 0, 1 0, that will become 3 times. 3 times we are multiplying. Here 2, 2 into 2, 4, 4 into 2, 8. And the 0 also 3 times it will come. 8000. Here 12 cube, 12 into 12 into 12, 1728. 13 cube, 14 cube is given, 15 cube, 15 into 15, again into 15, 3375. 16 into 16 into 16, 4096. Now what pattern do you notice in this table? Here we cannot say any particular pattern like the same way. Here in square numbers we notice that 2, 3, 7 or 8 ending, that number is not a perfect square. But in the case of cube, all these digits are coming here in the unit place. 0, 1, ending with 2 is there, 3, 4, 5, 6, 7, 8, 9. That means all the numbers are coming in the unit place. All the digits are coming in the unit place. Here we can see the same as that squares, fractions, decimals, and negative integer. We can find the cube. Cube of a fraction, 4 by 6 the whole cube. So 3 times we have to multiply. We will get here in place of 4 by 6 the whole cube means 64 by 216. Same way 13.08 3 times when we are multiplying we will get the answer. Minus 6 3 times. So 3 times minus into minus positive, again minus, it will come minus. And 6 cube is 216. Here can a cube end with exactly 2 zeros? No. Cube always it will come multiple of 3. Number of zeros, that will be multiple of 3. If we start the number with 1 0, that will come 3 times when we are multiplying 3 zeros. Now taxicab numbers. If the sum of two cubes in two different ways, we can write any number, then we can say that is taxicab numbers. It's called like that way. Here 1729 we can write as 1 cube plus 12 cube. The same number we can write in another method. 9 cube plus 10 cube. So these two cubes in two different ways. Sum of two cubes in two different ways are called taxicab numbers. The next taxicab numbers after 1729 are 4104 and 13832. Perfect cubes and consecutive odd numbers. Here 1, that is 1 cube. 3 plus 5, 2 odd numbers sum, which is equal to 8, 2 cube. Next is 3 cube, and that we know that is 27. This we can write as sum of 3 consecutive odd numbers, 7 plus 9 plus 11. 4 cube, that is 64. 64 we can write as the sum of 4 odd numbers. Same way, 5 cube 125, 6 cube the same. Now here can you tell what is the sum is without doing any calculation work here. Here we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers are there, which means 10 cube. 10 cube is 10 into 10 into 10. That means 1000. 10 into 10, 100, again 10,000. Here 1, 2, 3, 4, 5, 6 numbers, 6 cube. 5 numbers, 5 cube. 4 numbers, 4 cube, 3 cube, 2 cube, 1 cube, like that way. Next, cube root. Cube root also the same way. We can write that as root sign and inside 3 we got to write. Then cube root. Cube root of 8, which is equal to 2. Cube root of 8 or cube root of 1000, which is equal to 10. This cubic numbers we can write the definition. A number is multiplied by 3 times by itself. We get the cube of that number. 3 times 2. Cube of 2. That is 8. Then we are writing cube root of that 8. Cube root of 8 is 2. Cube root of 125 is 5. The number which one we multiplied 3 times, that will be the cube root. So we can write square root, we will mark like the same. Here cube root means we have to put 3 inside a small number, write in small 3 inside the sign symbol, and then whatever the number 125, which means cube root of 125 is equal to 5. The number 5 we have to multiply 3 times to get 125. Here also we can find the cube root by prime factorization method. Let us check 3375 is a perfect cube. 3375, first we have to do the prime factorization. After that we can see we have to make the group of 3. 5 3 times. So we have to group it like the same. And from that we have to take one number only. From here 3, from here 5. So 3 into 5 is equal to 15. That is the cube root of that number. Here 500 is a perfect cube or not. When we are doing the prime factorization, we are getting 2 times 2 and 3 times 5. So when we are making the group of 3, 5 is the group of 3, 2 only 2 times. One more 2 we need, which means 500 is not a perfect cube. Now that on the next page we can see some more examples like the same. 4 is equal to 2 into 2. This is the prime factorization of the number. When we are doing the prime factorization, that is here given. And the same way 64 we can do the prime factorization. We will get here 3 times 2 as one group, this is the other group. So cube root of 64, it will come 2 into 2, 4. Here one group of 2, one group of 3, which means cube root of 216 is equal to, take 1 2 from here and 1 3 from this group. So 2 into 3, it will become 6, which means 6 cube is equal to 216. Similarly 15, 12, etc. Now find the cube root of these numbers. We can do the prime factorization of this number. Here the first number 64, cube root of 64. For that first you have to prime factorize 64. Here we are getting 1, 2, 3, 4, 5, 6 times of 2. That we had to make the group of 3 like the same way. Here 3 2's in one group, remaining 3 in another group. So cube root, put the root sign, cube 3 inside 64. Cube root of 64 is equal to, from the first group 1 2, from the second group another 2. So it will come 2 into 2, 4. So we can write cube root of 64 is equal to 4, or 4 cube is equal to 64. 4 into 4 into 4, 64. Next number 512. After prime factorization, here we are getting 9 times 2. One group, second group, third group. So cube root of 512 is equal to, from the first group 1 time, 2, second group and third group. So 2 into 2, 4, 4 into 2, 8, which means 8 cube is equal to 512. 8 into 8 into 8 is equal to 512. Next number 729. Prime factorization here. After that we are getting 6 times 3. So cube root of 729 is equal to 3, from here another 3, is equal to 9. 9 cube, 9 into 9 into 9 is equal to 729, or cube root of 729 is equal to 9. To find the square root, we are making group of 2. To find the cube root, we have to make the group of 3. Same digit or number, 3 in one group. Consider 3 numbers or digits in as one group and take 1 from each group. Here the successive differences. The perfect squares are there given. 1, 4, 9, 2 square 4, 3 square 9, 4 square. So 1, 4, 9, 16, 25, 36, etc. Then subtract second number minus first. 4 minus 1, 3, 9 minus 4, 5, 16 minus 9, 7, etc. And after that one more time, just subtract the second number, first number from the second. 5 minus 3, 2, 7 minus 5, 2, 9 minus 7, 2, etc. It is going on like that way. Now compute successive differences over levels for perfect cubes until all the difference at a level are the same. After some levels we will get that as same. So first we can do the difference of these numbers. these numbers, just there is not enough place to do different levels. So we can rewrite that here 1, 8, 27, 64, 125, 2, 16, etc. So first we have to subtract first number from the second. That means level 1. So 8 minus 1, 7. 27 minus 8, 19. 64 minus 27, 37. 125 minus 64, 61. 216 minus 125, 30. Now we are not getting the same numbers. So level 2. Again minus 19 minus 7. It will come 12. 37 minus 19. 18. 61 minus 37, 24. 30 minus 61, 30, here the difference 216 minus 125 is the difference 91. Then that 91 minus 61, it will become 30. Now we are not getting the same numbers. One more level we had to do. Level 3. 18 minus 12, 6. 24 minus 18, 6. 30 minus 24, 6. Now at level 3 we got all the numbers same. So that's what you are given till getting the same number as the difference. Here after 2 levels we got 2. In this case after 3 levels we will get 6, same number. Figure it out. Page number 16. First question. Find the cube roots of 27,000 and 10,648 by prime factorization. 27,000. When we are doing the prime factorization, we are getting 3 times of 2, 3 times of 3, 3 times of 5. So we can make the group of 3. So cube root of 27,000 is equal to, from each group one time we have to take 2, from here 1 3, 1 5, which is equal to 2 into 5, 10, 30. So cube root of 27,000 is equal to 30. Same way second number 10,648. Here group of 3. This also group of 3, which means cube root of 10,648 is equal to 1 2 from the first group and 1 11 from the second group. 2 into 11, 22. So cube root of 10,648 is 22, or 22 3 times when we are multiplying we will get 10,648. Second question, what number will you multiply by 1,323 to make it a cube number? That means this is not the cube number. So which number we have to multiply to make that as a cube number? For that, first we have to do the prime factorization of 1,323. So when we are doing the prime factorization, here we are getting 3 times 3 and 2 times 7. Which means when we are grouping group of 3, this is one group. Here in this group only 2 7s. We need one more 7, group of 3. Then only we can make that as a cube, or then only we can say that number is a cube. So the given number is not a perfect cube. Which means we have to multiply, we need one more 7. We have to multiply the given number by 7. Then it will become already here 2 7s. So when you are multiplying with one more 7, it will come group of 3. That also. So 1,323 3 into 7 is equal to what we are getting, 9261. And that is a perfect cube. So if you want the cube root of the new number, cube root of 9261, that will come 1 3 from the first group, 1 7 from the second group is equal to 21. So 21 is the cube root of 9261. This is the new number. Here the question, what is the number to be multiplied? So we can write the number to be multiplied is equal to 7. 7 is the number we multiplied. Therefore the number, so we can write it in sentence. Therefore the number we multiply 1323 to make it a cube number is 7. We multiplied that number with 7. Then the new number is 9261 and its cube root is 21. So the number which one we multiplied, that is 7. Third question, state true or false. Explain your reasoning. The cube of any odd number is even. That is false. Cube of odd number is always odd. We can go through the example. You can write that one. The cube of an odd number is always odd. So that statement is false. And example, 3 is an odd number. Cube of 3, 27, is again odd number. 5 cube, 125, odd number. 7 cube, 343, odd number. That means cube of an odd number is always odd. So the given statement, the cube of any odd number is even, that is false. Second statement, there is no perfect cube that ends with 8, that also false. We can see all the cubes of the number ending with 2, that will end with 8. Here, that statement also false. The cubes of the numbers ending with 2, the number is ending with 2, then its cube will end with 8. For example, 2 cube 8, 12 cube, the number with 2 at the unit place. Then 2 into 2, 4, 4 into 2, 8 will come. 22, 32, etc. So the given statement is false. Third statement, the cube of a 2-digit number may be a 3-digit number. That also false. Cube of a 2-digit number cannot become 3-digit number. Cube of 2-digit number, that will be 4-digit or 4, 5, 6 digits, like that. So we can write that also false. Cube of a 2-digit number have 4 to 6 digits. The smallest number, 2-digit number is 10. Its cube itself, it is coming 1000. That means 4 digit. So minimum 4 digits will be there, the cube of a 2-digit number. Next question. The cube of a 2-digit number may have 7 or more digits. That also false. 2-digit number, the highest 2-digit number, that is 99. And cube of 99 is having only 6 digits. So it cannot come that as 7 digit. The highest 2-digit number, that is 99, and its cube contains 6 digits only. So 7 cannot come, that's why it is false. Same way, the 2-digit number, smallest 2-digit number is 10, and it becoming 1000, 4 digits. So cube of a 2-digit number lies 4 digits or 5 digits or 6 digits, maximum 6 digits. Now fifth point, statement, cube numbers have an odd number of factors. That also false. Cube numbers have odd or even number of factors can come. Example 27. 27 we can write as 1 into 27 and 3 into 9. So the factors are 1, 3, 9, 27. 4 factors are there. Even number of factors we are getting. So odd or even can come. So all these statements false. Fourth question. You are told that 1331 is a perfect cube. Can you guess without factorization what its cube root is. Similarly, guess the cube root of these numbers. We know that we can do the prime factorization and can find the cube root. But here without prime factorization. For that, first we have to write the number 1331. 1331. Then we have to make a group of 2. The first 3 digits in one group, the remaining the digit in the second group. So first group is coming here 331. This is the first group, this is the second group. In the first group, the unit place digit is 1, which means 1 cube. 1 cube is 1 itself. The unit, so the cube root of this number, unit place digit, that will be 1. And here this one lies between 1 cube and 2 cube, and it's 1 itself, so it will come that as 1. So the cube root of that number is 11. The next number 4930. 4930. First we are making the group from right to left. This is the first group. This is the remaining digits that will be in the second group. In the first group that contains 913, we know that the unit digit is 3. 3 is coming the cube of 7, which means 7 cube is equal to 7 into 7, 49, 49 into 7, 343. So this 3 ending, that means the number will be ending with a 7. So unit place digit we can put that as 7. Now the remaining number here, the second group 4. That 4 lies between the cube of 1 cube and 2 cube is 8. So 4 is coming in between 1 cube and 2 cube. 1 cube is 1, 2 cube is 8. 4 comes in between these two. So take this number, the lowest number. So 1. 17 is the cube root of 4930. The next number 12,167. 12,167. Here also we are making the group. First 3 digits in the first group, then the remaining digits in the second group. Here the digit ending with 7, which means the unit place digit will be 3. 3 into 3, 9. 9 into 3, 27. That 7 is coming here. So look at the unit place digit. And 7 comes when 3 is there in the number, unit place. 3 into 3, 9. 9 into 3, 27. That's 7. Now the second group is 12. Look at that 12 lies between 2 cube and 3 cube. 2 cube is 8. 3 cube, 3 into 3, 9. 9 into 3, 27. So 12 is coming in between 8 and 27. That means in between 2 cube and 3 cube. From that, we have to take the lowest number. So 2, it will come in tens place. The cube root of 12,167, that will come as 23. Then one more number, that is 32,768. Here first 3 digits in group 1, remaining digits in group 2. Here the number ending with 8, which means the unit place digit will be 2, because 2 into 2, 4, 4 into 2, 8. The number is having 2 at the unit place, that will end with 8. Cube of that digit, that number will end with 8. Now here 32. Now already we know that 3 cube is 27. And 32 is coming in between 3 cube and 4 cube. So 32. The 3 cube is 27. 4 cube is 4 into 4. 16 into 4. 64. So 32 comes in between that. Take the lowest number 3. So that it will come in tens place. So cube root of 32,768 is equal to 32. So we got the answer. The first one is 11, then 17, 23, 32. Without doing the prime factorization, we can find it like the same. First we have to take the from right to left. 3 digits as the first group, remaining digits as the second group. Then look at the unit place digit. Cube of 2, that will come 8. Cube of 3, that will come 7. 3 into 3, 9, 9 into 7. Cube of 7, it will come end with 3. 1, end with 1. So, unit place digit we will get. For the tens place digit, look at that number. 30, remaining numbers 32. Lies between the cube of which are the numbers. So, between 3 cube and 4 cube. So, take that lowest one, 32. Here 12 lies between 2 cube and 3 cube. Take 2. This is the way we can find without prime factorization. Fifth question, which of the following is greatest? Explain your reasoning. Here we have the reason, that is n plus 1 the whole cube minus n cube. The bigger number cube minus the nearest numbers cube, smallest nearest number, that will be equal to 1 plus that bigger number into 3 into smaller number. So here we can take 67 is the bigger number, 66 is the smaller number, and 1 plus the bigger number, that is 67, into 3 into n is 66. So 67 into 3 into 66. Here also same, 1 plus the bigger number, n plus 1 means 43. That into 3 into 42. 3 into 42. In the case of square, one number square minus the other one, it will come 2n plus 1. So here 67 square minus 66 square. 2n means n is the smaller number. 2 into 66 plus 1, it will come 133. 66 into 2, 132 plus 1, 133. Here 2n, 42 into 2. 84 plus 1, 85. So the answer we are getting here 85, here 133, and here 1 plus 43 into 42 into 3. Here 67 into 66 into 3. So this is the bigger number. We can write here the first one, 67 cube minus 66 cube is the greatest. This is the rule of that. For that to solve. First one, in place of cube, we have to take 1 plus n plus 1 into 3 into n. Squares, that is 2n plus 1.